Okay, so the first thing I'm going to do is we did square root transformations. All right, so the first thing with square, and you can just watch for a second. I want to just go over some stuff before we start the notes today. So first of all, on the square root transformations, you always start from the 0 point where the vertex is. And this should be at 0, 0, but it shifted which way? 2 to the right. So my h is 2, my k is 0, and then this is where all of you started making crap up. So the a is rise over run. So how many did I go up? How many did I go over? 1, and I take the square root on bottom. So 1 over 1 is still 1. So the a here is 1. So the next thing you want to look at is which way does the arrow go? And if it's facing the correct way, it's up to the right. So nothing is negative. So some of you just made everything negative for fun. But nothing is negative. So then when I fill this in, I'm going to get x minus 2. And why is it negative 2? X's lie all the time. So next, which way is this pointing? Up. So am I going to have a negative? No. So the next thing I want to know is this point should have been here. So which way did it move? It went up 1, so that's my k. And how far did it go over? Negative 4. Now my a value, rise over run. How many do I go up? I went up 3. How many did I go over? 1. And I take the square root on bottom. So what's the square root of 1? So the a equals 3. So when I do this, I have 3. So what about this one? Which way does this arrow point? Down. So this time, it's a negative. Then I went over how many? 2. How many did I go down? 4. So now I want to do rise over run. 1 and 1, it's still 1. But where does this negative go? It goes outside. So we're going to have negative. Which way do these go? Down. So this is a negative outside. So it's a positive when it points up, and it's a negative when it points down. All right. So then I do want to go over a couple of these. Because they're multiple choice and it's words, you guys just skip them. So I counted them wrong for you. But so this one. Except for the point 0, 0, the graph y equals the square root of x is entirely contained within the first quadrant. So that's true, right? Here's the square root, first quadrant. That's true. Then it says, which quadrant will contain this graph? So, which way, what do I have underneath the square root? Negative. So I have to take out the negative, so I get x plus 1. So what does the negative tell me? Over which axis this time, though? Y. So that means this is going to flip which way? This way, right? So which quadrant is it in now? It's in the second. All of you missed this. I don't understand. You just flip it. It wasn't even an upper level question. I think most of you got this one right. Oh, this one though. This is interesting. Okay, so be honest. How many of you just didn't do this because of the words? Right? All right, so I'm going to read this. Here's the parent function, and it's transformed to this. Okay? Parent function transformed to here. Which of the following best describes this? So first of all, I'm going to take the square root function, and which way does it move? To the right, correct? And what does the negative do? It turns it upside down. So all of that said, just tell me by looking at here, what do we know about the square root function? It has, underneath here, it has to be positive, right? Because we can't take the square root of a negative. So can this be 2? Can x be 2? Because 2 minus 1 is what? Negative 1, right? But what happens here? You square it. So is it ever going to be negative underneath here, no matter what number I pick? So x can be any number I want it to be. But no matter what I put in there, what's the final answer? Because of the minus outside. So which one of these is this going to be? The function is never positive, and it can be any real number, so it's A. Okay, and so I'm not being mean, but I'm seeing some of you stare at the floor. So I'm not doing this for my health. I knew the answers to this, and I'm not doing it just for fun to waste your Friday. You're going to see this again. Okay. All right, so since we're not interested in this, we'll just move on to the notes then. Move to the notes. Okay. What are you laughing at? I'm going to punch you. There is nothing funny, and I'm yelling. Be afraid. Thank you. Thank you. And why? Don't make her laugh. You're saying stuff and she's laughing. She's not just laughing. There's nothing funny here. I'm mad. Yeah, that's right, you are. Okay. No laughing. All right. So we're going to do x to the third, which is the cubic function. So x to the third is the cubic function. So look, this, what we did before was x squared. So you see this part right here? Instead of going up, it's going down now. And does anybody know why? So if you took x to the x squared, if I put a negative 2 in there, what happens? Negative 2 squared is positive 4. If I put a negative 2 in x to the third, I get negative 2 times negative 2 times negative 2, which is negative 8. So we need the negatives this time. So we're going to take this little bit and flip it down. 2 times 2 times 2. Oh, you look like you're confused for a minute. You got it? Okay. So the domain. You guys, the domain every single time is negative infinity to infinity. And the range is bottom to top, negative infinity to infinity. So every time, the domain is all real numbers, the range is all real numbers, there's only one y-intercept. And the parent function, the y-intercept is 0, 0. There's only one x-intercept, and in this case, they're the same. And the graph has rotational symmetry around the point. That means if I rotate it around, it's the exact same way if you turn it upside down. That's what that means. So what's the difference between this graph and this graph? Very good. Look at you. Good words. So this one's vertical and this one's horizontal. So the cube root is also negative infinity to infinity. And here's the points you're always going to use. For this one, we're going to use 1 and 1. And what points are we going to use down here? So if I have negative 1, it's still -1. But they just stretch differently, right? Okay. So the x's lie. So the -4 moves forward to the... Okay, thank you. The -4 moves forward to the right. The +2 moves forward to the left. If they're not inside the parentheses, this is an up and down. So which way did this move? The first one. This point should be here, right? So it moved how many? 2. And it moved to the right, and it's a liar, so it's x -2 to the third. This one moved up 3, so this is going to be x to the third plus 3. And what's the domain and range every time? No matter what. So negative x to the third flips it over the x-axis. So that means that the -1 goes up here, and this goes down here, and now it looks like this. So when it's not negative, it points up to the right. But now this points down, so it is negative on the outside. Okay? What happens if I put a negative on the inside? It flips over the y-axis. So if it flips over the y-axis, originally, where was this? It's over here, right? So it's going to flip, and it's going to end up looking the same as this one. So why do they look the same? Why do those negatives look the same? Because they're in different places. This is what it should look like. This is the original graph. So if I flip it over the x-axis, where does this go? Down, and this goes up. If I flip it over the y-axis, where does this go? Over, and this goes. So it ends up being the same. Okay? And that's because it has rotational symmetry. So if you rotate it, it doesn't matter which way it goes. It always ends up looking the same. All right. So given the parent function f of x equals x to the third, write the equation for the given transformation. So what this tells me is, you see where that f of x is? I'm just going to put x to the third where the f of x is. So I get 2 x to the third plus 3. Means I get a stretch of 2 and 3 up. And does the domain and range change ever? Nope. No matter what I did to it, negative infinity to infinity. So what about the next one? I'm going to rewrite this with an x to the third. So that's going to give me negative x plus 1 to the third. So the negative is on the outside. So that's a reflection over the x-axis. And I move 1 to the left. And the domain and range are still negative infinity to infinity. So the cube root, it works exactly the same way. Exactly. So where should this point be? Right there. So which way did it move? Down 2. It's pointing up to the right, so it's still positive. So this time I'm going to do the cube root of x minus 2. Because this one is laying down, so this is the cube root, not the square, the cubic. So here's the 0 point. Which way did this move? 3 to the left. So cube root x plus 3. So if the cube root is flipped over the x-axis, it's supposed to go up here and down here. So over the x-axis, where does that go now? If it's not up, it's going to go down, right? And if I flip the original over the y-axis, what happens? It's the same thing. So this time we're going to write with the cube root. So this is going to be 5 cube root of x plus 5. That's going to give me a stretch of 5 and 5 up. And the last one is going to be a reflection over the x-axis. And then 7 to the right. Is that your last one? There's more?